Hey everyone, this is part 2 of our optimization video sequence. And this is example 2. So your task is to build a road from the small town of Sparto to I-80 to enable drivers to be able to reach Sacramento in the shortest time possible. How should this be done if the speed limit is to be 45 miles per hour on the new road and it is 65 miles per hour on I-80? The perpendicular distance from Sparto to I-80 is 30 miles and Sacramento is 50 miles down I-80. So let's remember when we talked about the how to solve optimization problems is we first thing read the problem, which is what we just did, and identify whether we need to maximize or minimize. And then what is it that we want to maximize or minimize? Keywords: largest, smallest, most, least, etc. So here, what is it that we want to do? Maximize or minimize? And we want to minimize, right? Because notice that it says we want to build a road from the small town. We want to enable drivers to reach Sacramento in the shortest time. So that is the shortest. So that is an indication of minimize. So we want to minimize time. How should this be done if the speed limit is to be 45 miles per hour on the new road, and so on? Okay, so we should probably draw a picture if we can. The fact that we have a perpendicular distance lets me know that we can probably draw a picture. So let's attempt to draw a picture. So we have Sparto to I-80, and that's a perpendicular distance of 30 miles, and then Sacramento is 50 miles down from I-80. So let's try a picture. All right, so then here's my picture. So I have Sparto, and then 30 miles down on the perpendicular fashion is I-80. Now we do want to build this new road that's going to connect Sparto to I-80, but we want to shorten the distance, right? So we want to the time, sorry. So if we go here and then that way, it's not going to do it. So then there's this, the red is the new road. And so at this road, what is the miles per hour? So the speed limit is to be 45 miles per hour in the new road. And on I-80, we can travel at 65 miles per hour. Now this is 30 miles over here, and then from I-80 to Sacramento is 50 miles. So this from I-80, right, when that perpendicular distance is here, 50 miles to Sacramento. So let's put in what we know. All right, so we want to minimize travel time. So let me add that in here. So we want to minimize travel time from Sparto to Sacramento. So that means that this is going to be time on the new road plus time on I-80. So that's where our equation is going to be. So this is going to be the total time. So essentially, where should this road connect from Sparta to I-80 so that we get travel on that road plus travel on I-80 to be the shortest amount of time? So that's what we want to come up with. So what is time? So time on the new road plus time on I-80. So we have distance, we have speeds, so we're going to use distance equals rate times time. And since we're looking for time, let's solve for time. Then time equals distance divided by the rate. So then our total time, which we know is time on new road, I'm just rewriting, plus time on I-80, that means this is going to be distance over the rate, right? Distance over rate. So solve for time, and distance equals rate times time. So then the time on the new road is going to be the distance of the new road divided by the speed on that new road. So do we know those? And that's where our picture is going to come in handy. So let's write what we have. So this is going to be distance on new road over the speed or rate on new road, right? Plus then distance on I-80 over the speed on I-80. And looking at our picture, we have the distance from Sparta to I-80, but I don't have the distance on the new road, right? We don't know what that is. So let's call it something else. Let's call it C. I know that's 30. And let's call this X. So if that's C, this here is X, then what is this distance? The total thing is 50, right? So then this will be 50 minus X. So then the distance on the new road is 60, or C, sorry, and then the distance on I-80 will be the 50 minus X. So when I go back over here for my total time, which is why we want to minimize, distance on the new road, which is C, over the speed on the new road, which is 45 miles per hour, plus distance on I-80, which is 50 minus X, over the speed on I-80, which we know is 65 miles per hour. Now, this is our equation for time, so I'm just going to call it capital T. And now you can see what's wrong with this. Not that there's anything wrong, but why can't we use it? I have two variables. So I can't find critical numbers. So we need to put this in terms of one variable so that then we can find the derivative and take and find critical numbers. Right, in terms of one variable. So how do I do that? So let's go back to the problem. So your task is to build a road from the small town of Sparta to I-80 to enable drivers to reach Sacramento in the shortest time. How should this be done? Okay. So there's nothing there that we missed. We already have the picture. So oftentimes the constraint may not necessarily be stated in the problem, which is why I wanted to do this example. So how can I get this to be either the X needs to be in terms of C or the C needs to be in terms of X? So this is where the picture is going to come in. I can't really do anything with the 50 minus X here to write it in terms of C. So what we're going to do is we're going to write C in terms of X because C happens to be the hypotenuse of this right triangle. So I can say, use Pythagorean theorem here. So I'm going to have a squared plus b squared equals c squared. So I'm going to have x squared plus 30 squared equals c squared. So c is the square root of x squared plus 900. And so that is our c. So notice that now this is in terms of x. So let's go back to our time equation. So time here, the total time is c, which we just found it to be the square root of x squared plus 900 over 45 miles per hour. And remember, c is distance, right? So this will be, if I put units here, this will be c miles, and this will be 50 minus x miles, and this is in miles per hour. Right, so miles divided by miles per hour gives you hours. So this will be, the units here are hours. And so it makes sense for time. So plus then 50 minus x over 65. Hours plus hours, and we have hours. And so now we have the time is a function of x. Right, now I have it in terms of one variable. Here, t is a function of c and of x, so I can't say anything. Now here I have it in terms of one variable. Now I can find the derivative. So let's go ahead and find the derivative of this. This I can write it as x squared plus 900 to the 1/2. Be careful not to say, oh, this is just x plus 30, right? The square root does not work like that. You can't square root over a plus or a minus. So what is the derivative here? You're going to have 1/2, the inside left alone, then times the derivative of the inside. So times 2x, and then you still have your over 45. plus the derivative of the second term, so negative 1 over 65. So this is our derivative, and simplify it so that we can solve for x. So my 1/2 here cancels with that 2. We can bring this negative 1/2 to the bottom. So on the top, we're just going to have x over, and then the 45 x squared plus 900 to the 1/2, so really square root, minus 1 over 65, and set it equal to 0. You can either get a common denominator, or here, because I have two fractions, I'm just going to leave the first one as is, and I'm going to subtract or add the 1 over 65 over, and this is going to allow me to then cross multiply. So after I cross multiply, I get, I was able to move this because I set it equal to 0. So there's my setting equal to 0. So I'm going to have then 65x, x times 65 equals 1 times 45 square root of x squared plus 900. And get rid of this square root by squaring both sides and then solving for x. So what do we get? So 65x squared, so that would be 65 squared, what is that? 4225. X squared equals 45 squared, which is 25 times then x squared plus 900, because here the square root cancels with the square, and distribute the 2025 in, so I'll have 4225x squared equals 2025x squared plus whatever this is, 2025 times 900. Big numbers here. Subtract the 2025 over to that side, so we're going to have 2200 x squared equals the 2025 times 900, and then divide both sides by 2200, so x squared is 2025 times 900 over 2200, and then take the square root to get x by itself. So when you take the square root, you always get plus or minus. So then this is going to be plus or minus the square root of that, which is, I get 28.78. So this is my x. Now x can't be negative, right? Because where is x? X represents a distance. On my picture, x is the distance from I-80 to wherever that road is going to go. So, and in fact, we can add a constraint here to x. X has to be greater than 0 because it represents a distance, but it has to be less than 50 because I-80 is 50 miles away from Sacramento. So you couldn't get, so if you got x to be more than 50, that means that there was an algebra mistake in your work. So x has to be between 0 and 50, right? So if x is 0, that means the fastest way is to just go directly from Sparto perpendicular to I-80 and then go the 50 miles to Sacramento. But now we just found our critical number, which is 28 point something, and so now we know that the fastest way to get to Sacramento from Sparta will be having this road come to about 28 and change miles from I-80, that perpendicular distance, and then travel on that road 45 miles per hour, and once you hit I-80 there, then go to the rest of the way to Sacramento at 65 miles per hour. So if you're a civil engineer or road architect, those may be things that you will have to deal with. So we can get rid of the negative because since x has to be between 0 and 50, then we're going to say then x has to be the 28.78. And then what is it that we wanted to do? Maximize or minimize? We wanted to minimize the travel time. So we want that 28.78 to be a minimum. So how do you check that it's a minimum? Because this first derivative is not pretty, I am not going to do the second derivative test. I will do the test point method for that one. And so I'm just going to go back over here and put my number line. And we have 28.78. That's our critical number. That's where the derivative t prime is 0. So we want to see what is the time doing. So plug in something, right? We know that x has to be between 0 and 50. So you could plug in 0. When x is 0, this will be 0. And so you're going to end up with a negative. So the derivative is negative, which means that the time is decreasing. And then something bigger than 28, you could put in 30. And so you're going to have whatever that is, minus 1 over 65, 30 over, let's see. So this is going to be, but this is going to be positive actually. And so double check it with your calculator, and then so that increases. So that means that you have a min at your critical number, which is what we wanted. We wanted to minimize it. So that means that 28.78, this is a minimum. Am I done? I don't know. What was the question asking me? Always when you're finished, go back. What was the question? How should this be done if the speed limit is to be 45 miles per hour on the new road and 65 miles per hour on I-80? So we want to find the shortest time. You want to build the road. So how should this be done? The answer will be build the road from Sparto in 28.78 miles into I-80. So however you want to answer that in your own words. So the road from Sparto to I-80 will have to be right when you go here, Sparto, and then the perpendicular distance to I-80. So from here, the road should end at a distance of 28.78 miles. So that's where this road should meet up with I-80. And then you can write that in a nice complete sentence. So hopefully this is helpful. I posted another video already on in your module to look at with a lot more examples from Professor Leonard, and so hopefully those help. Email me if you have any questions.